Let us learn how to identify the organic compounds using IR Spectra. What are you waiting for? Come learn with us. In this question number 1, the spectra is given, structures of the corresponding compound is given and molecular formula is given. So first let's see on the basis of the molecular formula, which is given C6H12 and O1, 6 carbons, 12 hydrogens and only 1 oxygen. Now let's see the given structures and count the number of elements present in each of them. For example, option A contains 6 carbons, 1 oxygen and 12 hydrogens. So this can be the answer as it has same number of elements mentioned in the molecular formula. Option B contains 6 carbons, 1 oxygen and 14 hydrogens. So this cannot be the answer as it does not have same number of hydrogens mentioned in the molecular formula. So this option is out. Option C contains 6 carbons, 2 oxygen and 8 hydrogens, so this cannot be the answer as it does not have same number of oxygens and hydrogens mentioned in the molecular formula, so this option is out. Option D contains 6 carbons, 1 oxygen and 12 hydrogens, so this can be the answer as it has same number of elements mentioned in the molecular formula. Option E contains 6 carbons, 1 oxygen and 12 hydrogens, so this can be the answer as it has same number of elements mentioned in the molecular formula. Now, if you see out of 5 choices, 2 are already out, option B and C. Now let us see the remaining choices A, D and E on the basis of spectra. If you see the spectra, you can clearly see a sharp and long peak around 1700, which means a carbonyl C double bond O group should be there in the compound, and only option D contains the carbonyl group. Moreover, option A and option E contains hydroxyl OH group, but in the spectra there is no peak or band in this region, which means option A and D are out as they do not have a carbonyl group. So the remaining option is option D, and that is the answer. In this question number 2, spectra is given and molecular formula is given. No options are there. That means you have to draw the structure of a compound from this information. Need not to worry, it is easy. See how many different elements are there in the molecular formula. This compound contains carbons, hydrogens and oxygen. For carbons, 8 hydrogens and only 1 oxygen. No other element is there. With this combination of carbons, hydrogens, and only 1 oxygen, we just have 4 choices. Maybe it is an alcohol, or maybe it is an ether, or maybe an aldehyde or ketone, because acid and esters contains 2 oxygens, amide will have nitrogen, acid chlorides will have chlorine, and hydrides will have 3 oxygens. If you see the spectra, you can clearly see a sharp and long peak around 1700, which means a carbonyl C double bond O group should be there in the compound, so alcohol and ether is out. Remaining option is aldehyde and ketone. For aldehyde, we all know that aldehydes will give 2 peaks for sp2ch stretching at 2820 and 2720, which is known as Fermi doublet, which are not present in the spectra. That means aldehyde is also out. Remaining is ketone. Now let us write down the structure of the compound from this information. Molecular formula is C4H8 and 1 oxygen, and it is a ketone. So ketone with 4 carbons will be butanone. So 2-butanone is the answer, and the structure of the identified compound is given here. If you see the spectra, you do not see any sharp and long peak around 1600 to 1800, which means there is no carbonyl C double bond O group, so aldehydes and ketones are out. Remaining option is alcohol and ether. We can clearly see the hydroxyl OH peak at 3352. That means an alcohol. Moreover, the CH stretching is less than 3000. That means all carbons are sp3, single bonds, so this alcohol is saturated. Now let us write down the structure of the compound from this information. Molecular formula is C5H12 and 1 oxygen, and it is an alcohol, so alcohol with 5 carbons will be pentanol, so pentanol is the answer. If you see the molecular formula, the compound contains only carbons, hydrogens, and nitrogen. That means it is an amine. But if you see the spectra, you do not see any peak around 3400, which means there is no NH stretching. That means the amine is tertiary, because primary will be a double peak, secondary will be a single peak, and tertiary amine will not give any peak at this area. So primary and secondary amine is out. Remaining option is tertiary amine. Moreover, the CH stretching is less than 3000. That means all carbons are sp3, single bonds, so this tertiary amine is saturated. Now let us write down the structure of the compound from this information. Molecular formula is C9H21 and 1 nitrogen, and it is a tertiary amine. So let's start from writing nitrogen in the center. And this nitrogen is tertiary, so it will have carbons on left, right and down. Carbons are 9. We can equally divide it 3 left, 3 right, and 3 down, and then we can give hydrogens to each carbon to make them saturated, and this is the structure of the identified compound. If you see the spectra, the carbonyl peak is at 1689. That means it is less than the peak value of ketone, which is 1715. Only carboxylic acids and amides have peak value less than ketones. Esters, aldehydes have more peak value than ketone, which is 1715. Moreover, the spectra also contains a broad band for OH in this area. So it is a carboxylic acid compound.
Do leave your answers in the comment box. Thank you for learning with us. Don't forget to like, share, and subscribe.